understand data patterns and trends. And here we have a chart that was created by William Playfair, who is sometimes referred to as the founder of modern graphics. He created this chart in 1786, and it shows a time series data set of exports and imports between England, Denmark, and Norway. You can see along the x-axis, Playfair has labeled different points in time, and on the y-axis, different prices are listed. And although data visualization can be traced to well before this time, it's not a modern development. Archaeologists have found different artifacts, including charts and maps that can be traced back to very early civilization in the early 19th century. And due to the efforts of people like William Playfair, more countries and people began to collect and compile large amounts of information on the population, economics, etc. And we can trace graphical representations in the more modern sense as we know it today due to the efforts of those people like William Playfair and also Florence Nightingale, who you may know for her work as a nurse, but she also created visualizations too. And she was appalled at many of the horrible conditions of hospitals during her lifetime, and specifically during the Crimean War. She created this variant of the pie chart to illustrate and highlight the fact that poor sanitation rather than battle was actually the reason why soldiers were dying during the Crimean War. Some people refer to this version of the pie chart as a rose chart. You can see that different parts of the chart represent different months in time. The smaller chart is from 1855 in April to 1856 March, and the larger chart is from April 1854 to March 1855. Each color represents a different cause or group of causes of death at those different time periods. This is another visualization created by Florence Nightingale of a bar chart illustrating the mortality rate of male English civilians with English soldiers in 4 different age groups. And Florence Nightingale was really believed in the power of visualization. And she wrote in a letter dated August 1857, "Whenever I am infuriated, I revenge myself with a new diagram." So this is something that both William Playfair and Florence Nightingale understood and worked on doing. Schroeder et al. Write that visualization transforms data into images that effectively and accurately represent information about the data. So visualizing data is a way that people can literally see and understand what is going on. If you fast forward to today, data visualization is all around us. This image was created by the visualization group Periscopic in this article called "The Real Difference Between Google and Apple." And this visualization compares innovation signatures, charting the last 10 years of patents filed at Google and Apple. It shows also how they operate differently, where Apple has a more centralized development structure and Google is more widely distributed between sources and new innovations. We can assume that in our current age of big data and information, being able to visualize data ourselves and understand it are key skills. And even though this is often associated with the sciences, it is a process that is interdisciplinary and all around us every day. So the main goals of visualization are multifaceted. They can be simply for exploring and understanding your data, for analyzing your data, presenting and communicating the results of your data, and also to promote engagement with your data. And data visualization can also be used for analyzing your data, for discovering whether or not it follows your expectations or maybe your hypotheses about your data. Goals 3 and 4 are intertwined depending on your audience and what your main central goal is for working with your data set. So some common terms associated with data visualization include statistical graphics and infographics, as well as information visualization. And depending on who you're talking to, some people will view these as more interchangeable, while others will say they are different. If we compare data visualization with infographics, there are key differences. Data visualization focuses on the graphical representation of data, but an infographic contains a visual representation of any combination of facts, events, or will be combined to create a narrative or a story, such as this infographic of infographics, which has many different types of data, graphics, and information. It even has a word cloud, as you can see in the corner. So before getting started with your own data set, and in order to select the best visualization possible, you may have some questions to consider, including who your audience is. Is it in your report for an essay? Is it for your professor? Is it for a journal you're submitting to? What am I trying to convey and accomplish with this data set? Are you trying to persuade, to inform, or convince your readers of your argument? And then, of course, very importantly, what kind of data you're using, which Keiko will get into very soon. And for your audience and goals, thinking about who exactly the visualization is for and what might work best for them. If the goal is exploration, maybe you would want to create a dynamic visualization, one that your audience can interact with. Is the goal explanation or persuasion? Maybe you want to create a very simple static visualization. Depending on these, your decision on what you choose to work with and create might differ. Again, you could make your visualization static or dynamic. So I have an example of a cellular automata, which is modeling dialect diffusion in the Linguistic Atlas of North America. You can see there are different options here for controlling what's going on with the spread of the data. So let's see, we want to check out thunder squall or thunder gust. And if you hit play, it'll show the diffusion of this dialect feature, which is pretty cool. And this is a really great example of a dynamic visualization that a user or audience member can interact with. And you can obviously change the settings. We have the link available too if y'all want to check it out later. But going back to our slides. So that visualization was created by Juso and Kretschmar to visualize linguistic atlas data and patterns of distribution of a linguistic item. But you can do this with many different types of data, as Keiko will explain.
All right, so for this section, we want to just try to get into the practical side of doing data visualization a little bit more. So the first thing that you're going to want to do when figuring out how you want to display your data is to determine first what type of data you're working with. And there's two types of data, the first of which is quantitative data, which is basically any type of data that works with numbers. And it falls into two different types as well. So the first is discrete variables, and these are the types of things that are countable. So for instance, if you want to track how the population of a place has changed over time, then the number of people is going to be a discrete variable. Same for something like the amount of money that a company spent over the course of a year, or the number of tweets made by a certain account if you're doing some sort of linguistic analysis, or how often a certain word appears in the body of literature. So these are all discrete variables. There's also continuous variables, which are basically those that can take any value to any number of decimal places. So things like temperature or distance or time. And then there's qualitative or categorical data. And this is data that falls into labeled categories, so that when you're collecting your data, you'll label this thing maybe with colors or genres. So for example, if you wanted to see whether a school had more of a liberal arts versus STEM focus, you might look at the number of students in different majors. And this category of college major would be a qualitative variable. You get this a lot when you're working with data that focuses on people, so with doing demographic information. So this can be anything like gender or race or ethnicity, things like that. So these are the two main types of data, and which ones you're working with are going to govern the types of data visualizations that are most useful. So the next thing you're going to want to think about is how your data relate to each other. So if you're working with categorical variables, you're likely to be looking at percentages of the whole. So questions like, how many people in this field are women? What percentage of the time did a person participating in an experiment choose the correct answer? And if this is the case, you might want to consider something like a bar graph or a pie chart to visualize the data. And a hint that we always give is you want to go with the bar graph instead of the pie chart. There are problems with the human perceptual system that make pie charts less useful. The humans are much worse at estimating area than they are at estimating length. Bar graphs typically work better, but either of these are options for representing part of the whole data. Bar graphs are also a good option when the variable you're looking at is a categorical variable, but you want to see the number of items in each category. Or an average of things in categories. So like how often a specific word appeared in two different texts, or different breeds of dogs, looking at their weight in the average weight of dogs in each breed. Another option is that you might have two continuous variables. And in that case, you're likely to want to look at how they correlate, which is when you might want to have something like a scatter plot that's got a continuous variable on each axis and show what kind of relationship those have. When you're working with continuous variables, you often also might want to look at how the data are spread out. So where is the center of the data? How much does it spread out? Where are the outliers? Things like that. For something like that, you might want to use a box plot. You could also be tracking data over time, in which case you might want to use a scatter plot or a line graph. And then finally, you might be working with geospatial or mapping data, where you're looking at how a variable differs geographically and would want to see your data plotted on a map. And the one we have here is a map showing the speakers in the Digital Archive of Southern Speech, showing what are the locations of the speakers who are part of this corpus. So this is a very simple example of a geospatial map, but you can also have some that are more complex. So maybe the dots are coded by the rate at which a speaker did something specific in the corpus, or showing geographically how different states differ by some variable, something like that. So there are a lot of different options for mapping. This is something that we're going to talk about as part of our data visualization workshop series later this semester. So as I go through this presentation, you'll hear me say this a few times, that these will be different things that we discuss as part of our later series. There are a lot of options for data visualization, and the DigiLab is here to help with a lot of them. Some common types of visuals include charts, tables, graphs, maps, infographics, dashboards, a lot of things that we just went over, lots of different options that you might want to consider. So there are lots of different resources for data visualization, and you can find links to a lot of useful options on our DigiLab website with several tutorials about how to use specific ones for different purposes. Some of these might just be websites where you input your data and it will guide you through the steps of making different types of graphs. Others might be software you install to get a particular type of more complex visualization, like a network graph or a map. But today I'm going to be going over three of the most popular and multifunctional resources, Excel, Tableau, and R. So Excel is one of your best starting points for data visualization. Many of you are probably already familiar with doing lots of things in Excel already. If data visualization is something that you're new to, then it's one of the best places to start because it has a very easy access point. There can be a bit of a learning curve with like doing things via formulas or learning how the chart design functions work, but it's generally pretty quick and easily accessible. And because it's been around for so long, it's also very easy to find sources online for things like, how do I do this formula? How do I make this type of edit to a chart? You can usually get like some sort of standard Microsoft Office answer, and also just people online on forums who have very simple answers to these questions that are very easy to understand. In terms of stats, Excel formulas are a really transparent and easy way to look at at some of the basic attributes of your data. So for things like finding the average for subsets of data, Excel can be really useful, especially if you use the pivot table function, which kind of does all the work for you. And it doesn't require any sort of scripting knowledge, although the formulas, if you do have a bit of knowledge of the formulas, you have more power in Excel, but it doesn't require a lot of extra knowledge. You can just go right in and get started. So this is an example of what the interface of Excel looks like when you're in the process of designing a graph. Here, I just made up some sample data. I have it in the columns on the left, a graph I created from that data in the middle, and on the right there, the box there shows all the different types of available charts that might work for this data. And as you can see, there are a lot of different options available, and when you generate these, you can just click through, see which ones look best. Or if you know which type of chart, you can start there. Even the ones that don't initially look like the type of chart that you're visualizing can usually be tweaked to group the data together in a way that makes sense and is attractive for your data. So for example, if you're working with lots of different variables at once and you want to have your columns beside each other, but Excel is doing it in a way where they're stacked on top of each other, there are usually ways to go into it to edit it that are very simple. So odds are that in most cases you can find the type of graph you need and can customize it to make it look attractive. Excel, as it showed on the previous slide, includes a wide range of different chart options like bar graphs, histograms, has scatter plots, box plots, area charts, even some mapping functions. So the next one I want to talk about is Tableau, which may or may not have heard of, but it's an up-and-coming tool that I have not personally used much. But at the DigiLab, we've seen it becoming more and more popular over the past couple of years. And so we wanted to include it in our overview as an option. It's become especially a big deal in the business world because it has the ability to create extremely advanced graphics for the purpose of things more like infographics. They can also be like very interactive. Tableau does have a free version and a paid version. The free version is called Tableau Public. I haven't completely found what the boundaries are between the free version and the paid version. It seems like the free version has most of the necessary components for creating very advanced graphs, and most of the paid features relate to sharing your data online. And this relates to the fact that one of the main features of Tableau, which may be an advantage to some people, may be a drawback to others, is that the storage of graphs is almost entirely online. And this is meant to make it easy to put your graphs into online plugins, like be able to insert it into a website. That's especially useful for animated graphs or graphs that are interactive. I also get the impression that it's meant to be a sort of collaborative community where data is being shared freely. But if what you want is a simple graph to copy and paste into a research paper to just quickly turn in for an assignment, Tableau can be a bit tricky to get just plain JPG or PNG files from. There are ways to do it, and we do have tutorials on the DigiLab website that explain how to do that, but it's not always just as simple as right-click and download or something like that. In my opinion, the learning curve for making graphs in Tableau is a bit steeper than Excel when you're starting out, but it functions kind of like Excel's pivot table tool, where you select individual variables in your data set as the X and Y variables, and it makes the graphs for you, which is really nice. And there are also a lot of tutorial videos on their website that can walk you through the process. And Katie, can you go to the next slide and then come back to this one later? So yeah, this is what the interface to Tableau looks like. When you start out, you've already collected your data into a spreadsheet. You can't edit it within Tableau itself. So you'll want to have already put your data in Excel or some other spreadsheet and then uploaded it here. So this is some data. This is some data from my own research. All the variables are shown on the left. Normally you might not have like 30 variables or whatever I have. So sorry for the overload there, but as you can see, it's already preloaded it with labels as either categorical or quantitative data. So the ones that say ABC, these are categorical or written variables, and the ones with like the number sign are numerical data. And so this makes it very easy to like figure out what types of graphs you might want to make. So what you do is you can click on a variable on the left, drag it to the cells that say columns and rows, and this can allow you to choose what your X and Y axis are. You can also drag variables into the section on the left that says marks. So here I have my data divided by the type of task that my participants were doing. I was collecting linguistic data, so I had a reading task and an interview task. And here these are color-coded. What are the averages for the reading? What are the averages for the interview? And how did those change over time? This is a very simple type of graph. This is just what happens if you just quickly drag and drop some of your variables, but it can get much more advanced. And over on the right, you can see the types of charts that are available, which are very similar to the ones in Excel, but can again be customized a lot. So I'm going to share my screen and show some of the couple of examples of options for people who have expertise with Tableau, like some of the things that they have generated that are available on the Tableau website. So here is one of the visualizations that they have on their website. It's shark attacks in the US over the past century. And so you can see they've done a sort of bar chart, number of attacks per year over the past century, but also if you hover over each one, it gives more information like location, what was happening at the time. So you can see this particular shark attack in 1957 was provoked, where the diver attacked the shark first. And as you can go over each one, it'll just tell like what happened each time. It also has this subset of cases per region. So it's just like this nice little infographic. And you can also highlight what was the activity that was happening at the time. There's sometimes a lag on the website. when you try to do the interactive features. These were the people who were swimming. These were the ones who were surfing and so forth. Another infographic on their website. Let's see if this comes up. Okay, it says must read books by Black authors. And so this is an infographic. I probably can't see the titles very well on each of these because of the size, but if you hover over each one, it gives a summary of the book, tells who the author is. They're color coded by genre, and you can also use the interactive functions to like only choose fiction books, and it will remove the nonfiction ones from the shelves. So like very cool things can be done using the Tableau software if you are able to get to the really advanced functions. And then finally, I want to talk about R, which is another one of the most popular ways of generating graphics. R is primarily a statistical program so for analyzing data, but it also has the ability to create really cool and extremely customizable graphics. It can be a bit intimidating to get into R because you give it commands in a scripting language, so it can initially look very technical, but what it does very well. So if you plan to do a lot of work with quantitative data or in a scientific field, or even if you're not, if you're just going to be working with quantitative data in general, I would highly recommend picking up R as a skill. It is very valuable and has a lot of flexibility. R practically has endless possibilities for data visualization. You can do things not just like a standard bar chart or pie graph and things like that, so forth, but you can arrange your data in ways based on statistical models. You can generate like hierarchical graphs or like interactive branching graphs, network graphs, all sorts of things. It also makes it possible to group data in ways that go beyond what you can do with Excel, like grouping things by multiple variables at once. It's also able to handle really, really large data sets. So there have been times when I was working with corpus data that would have millions of words, and I wouldn't even be able to open the data in Excel because it would just have too many lines and it would crash the program. R doesn't have any problem with that at all. You can create graphs using the standard base R, but by far the prettiest graphing tools are in the ggplot package. And the DigiLab has lots of resources on our website showing how to use it. We also are going to be offering some data visualization workshops later in the semester, and several of those are going to be working with R and with ggplot to show how to create those visualizations. There's also tons of documentation online about how to get started with R, do intermediate level stuff, do crazy advanced stuff. There are forums practically just dedicated entirely to that. So if you need help getting started, those are always options, but we also hold office hours in the DigiLab. Both Katie and I have experience working with R, and we are happy to help people get started.
So some more options with R include creating dynamic and interactive visualizations. So Leaflet is a great R package for creating maps. Plotly is another really wonderful one for also creating 3D charts and options. And then Shiny is another one which you can use to build applications, build apps, and it gives you the opportunity to create dynamic and interactive visualizations. Here is a link to the Gazetteer of Southern Vowels. We're both linguists, so we use a lot of linguistic examples. And as in this app, you can, as the user, decide what different words you want to see visualized. It also has a map. You can select speakers from different areas of the Southern US and visualize their different vowel spaces, which is really cool. And like Keiko said, R has endless possibilities, and we highly recommend that you use it. If you're into using Python or you want to get started with it, Python also has lots of options for data visualizations. Probably the most popular library for plotting data in Python is matplotlib, which is designed to resemble MATLAB. And it works well with other popular Python libraries like pandas. ggplot from R also works as a plugin into Python, and it works in the same way as ggplot, where different plot components and aspects of your visualization are layered in order to complete the full image. And it also integrates well with the pandas library for working with different types of data. If you're working with maps or geographical data, then you would probably want to use geoplotlib in Python. But again, there are many different library options. If you're more into web-based resources and not into programming, these are some really good options. DataBasic is an easy to use and beginner-friendly web-based suite of data visualization tools. Rawgraphs works well with CSV and spreadsheet input to visualize your data. And Infogram and Datacopia work well for creating infographics and building into your reports. 440 ways to visualize text data was created by the Isovis group from Sweden, and gives you lots of options for working with text data. The Isovis group also created this machine learning models and visualizations options, if that is the type of data you're working with. And again, for geographical data, two other options include ArcGIS and QGIS for creating maps. If you want to read more about data visualization, these are really awesome and wonderful. Visualizing Data and Elements of Graphing Data by William Cleveland include a lot of basic information about data visualization. And the visual display of quantitative information, visual explanations, anything by Edward Tufte is really wonderful and beautiful. So I definitely recommend checking that out. Information is Beautiful is super cool because it includes a wide range of data visualizations from art, from science, lots of different disciplines. And he also has an accompanying website that we have a link to also here. And the Visualization Toolkit is a very helpful textbook read on this topic if you like reading textbooks. More recommended reading, these are some different articles we've got links to. Design Methods by Amy Coe is really awesome, and it has a computer programming background and information about data visualization. If you want to start using R and ggplot, definitely check out Hadley Wickham's A Layered Grammar of Graphics. The Bad Data Guide is really cool because it discusses different data processing issues for data visualization. And then A History of a Timeline is very cool and goes into some of the background with that. A Tour Through the Visualization Zoo goes through lots of different data visualization options. And Visual Thinking for Design goes into some of the science and cognition between decisions for your visualizations, like why a pie chart is harder for people to understand. And then if you want more about geographical data and GIS resources, you can check out this article by Emily McGinn and Megan Duver. We mapped it so you don't have to. And Megan is also available for consultations and happy to help if you need help with geographical data. Some recommended websites. The first is a link to data2viz.com, which is an overview of different types of graphs depending on your type of data. Information is beautiful, mentioned earlier by David McCandless, is very cool. And the Excel chart cookbook from Duke Libraries has a really quick and easy tutorial for different Excel charts. And the Data Viz catalog includes information on a wide variety of charts if you want quick and easy reads on this information. Okay, last bit of recommended websites. Most of these are relevant to working with R. Visualizing text data with ggplot2 is an excellent overview of ggplot by Colin Fay. And the ggplot2 cheat sheet I still use regularly, and basically anytime I'm working in R and ggplot, it'll help you look up different functions very quickly in the syntax of creating your visualization. Mastering Shiny is awesome if you want to create a Shiny app or a dynamic visualization in that environment. And the Tidyverse blog is also very helpful for data processing and preparing your data for visualizations. Some additional resources at UGA include LinkedIn Learning. And as a student at UGA, you have free access to it. They have many awesome tutorials for data visualization in Excel and in R. Tableau also has freely available tutorials available at our link. And we have tutorials from the DigiLab online. And did we mention again our upcoming data visualization series this fall, which will work with different types of data and tools. Our Ladies Athens is a great group if you're wanting to get into using R. We have meetings, multiple meetings across each semester, also via Zoom. And there's upcoming courses at UGA relevant to data visualizations. And finally, we have our DigiLab data consultations. If you need help and want to meet with us, please feel free to reach out, schedule an appointment at digi.uga.edu/resources, and we will be more than happy to help you get started. So thank you all so much for listening. Please feel free to reach out if you have questions, comments, or go ahead and ask us now. Here are our works cited, and thanks so much.
Katie, can you send me the presentation so I can send it to our attendees? Is that something?
Of course.
Awesome.
Yes.
Great. Thank you.
Yes.
Just wanted to address a couple questions I've been seeing in the chat. One of them, can you make an account on Tableau public? Yes, that's possible. I think to be able to do anything on it, you have to create an account, but that can be done on the free version. Also, there are already some R tutorials available on the DigiLab website, and this would be on the tutorials page. If you go to digi.uga.edu, there's a resources page, a tutorials page. There's already lots of stuff available on Excel and R. We'll also have some of those workshops later in the semester, so that if you want to hear it live, but there are some things on the website that are already available. And I put the resources page in the messages.
Thank you all so much. That was so informative. And I think Keiko recorded it and Katie's going to send the slides. So I'll make sure that all of that gets disseminated to our attendees today.
Thank you.
Awesome. Thanks, everybody. Don't hesitate to reach out if you all need help.
All right. Thanks, everybody.
Thank you.